For anyone that wasn't here yesterday, I did post yesterday's video on YouTube as well. You should be able to see it on Twitch or YouTube. And this is going to be the page that we're going to start with today. We're going to do the rhombus and the square today. And then if we have time, we'll do some of those coordinate geometry proofs. Alright, so it is 11 now, so I'm gonna get started. There's only 16 people in here, which means quite a bit of you, about 10 are not here right now. If you know people are not here, please just remind them to look up the old videos so no one gets too far behind. Yeah, skippers. I mean, what, 40 minutes a day? It's better than 6 hours, so it's not too bad. So just remind them to look up on either YouTube or on here to see what we've done in the past, because this is definitely something that you don't want to miss too far. You don't want to get too far behind with these properties. Today we're going to do the rhombus and the square. If we have time, we'll start maybe a proof, a coordinate geometry proof. If we don't have time, we'll do that tomorrow. I will be streaming tomorrow. I know under normal circumstances you would not have had school, but that superintendent's conference day was pretty much pushed to Monday that we just had. So I'm going to continue to do this tomorrow and then all of next week. So that's kind of the plan. I put up the answer keys beforehand. If anyone wants to see the answer keys to the homework, I can do so after today's lesson as well. For anyone who wants to see it, if you have specific questions, you can ask them to me if the answer key is not sufficient. The streams are roughly 40-45 minutes. I'll be on for the full hour. I'll usually end it all around 11:40. If you have, in that 20 minutes, you have questions, and then I start my physics at noon. But this should be the packet that you have out. We are going to jump right into it. We are going to discuss the properties of the rhombus. Plural being rhombi, which is why it's spelled this way in the notes. So rhombus is just a single rhombus, rhombi, multiple. Do we need graph paper? I don't know. It depends on how far we get. Right now I'm going to say no, but later on. I also don't know why it's doing this. It appears to just kind of shut off on me every 5 minutes, so I just have to put it right back up. But I'm not sure why it's doing that. But I don't know if we'll need graph paper. We'll see how far we get along. So let's jump into the properties of a rhombus. So the best way to kind of think of what a rhombus is basically that typical slanted square. So just like a parallelogram, but you can look at kind of number one right down here. And the difference between, a parallelogram we could call a slanted rectangle, which is fine. And then we could also call a rhombus a slanted square. And the biggest kind of thing to distinguish the difference between the two is that in a rhombus, all sides will be congruent. Unlike a parallelogram where it's just opposite sides, it is going to be all sides are congruent. Which we can put a little caveat to this, being that if one pair of adjacent sides in a parallelogram are congruent, then it's going to be a rhombus. Kind of like yesterday we discussed in a rectangle, I mentioned that if you have a parallelogram that has at least one right angle, it's a rectangle. This is kind of like that, but with sides being congruent. So if one pair of adjacent sides are congruent, then it's a rhombus. This is only true if the previous shape was a parallelogram. You'll notice right at the top it says rhombi have the same properties of the parallelogram. That is important. A rhombus is still a parallelogram. You can't have a rhombus without it being a parallelogram. So all those properties are still going to be true, and that's why they're all written up here again, just like they were in the notes yesterday for the rectangle. The other property, which is definitely going to be, I think, new, at least all sides being congruent, that shouldn't have been new. That should have been something you learned in middle school. The new one is going to be with its diagonals. And the diagonals are always going to be perpendicular. In any rhombus, you draw the diagonals, they will be perpendicular, meaning right in here forms right angles. You have 4 right angles right in here. So diagonals are perpendicular, which is great. That means all of those triangles, the little triangles that are constructed in a rhombus, they're all right triangles, which means you could do a bunch of Pythagorean theorems, so SOHCAHTOA. You have a lot of different rules that we have with right triangles, just because of the fact that diagonals are perpendicular. Another unique property, this one probably comes up the least often, but it's a good one to know, is that this is going to be the shape where the diagonals bisect their angles. What that means right here is these two angles right here, right by J, they would be congruent to each other. And that also tells me that if those angles are congruent and the parallelogram opposite angles are congruent, these angles are going to be the same exact thing down here. As well as you're going to see the same symmetry between M and K. But M and K are going to be different angles. So I'm going to give them 2 arcs, and then one down here, 2 arcs as well. So we have, all because in a rhombus, the diagonals bisect their angles. And that's how I'm going to word property number 3. Diagonals bisect their angles. Which, if we remember yesterday, this was not true in the rectangle. This was not true in an ordinary parallelogram. This is going to be a property that is unique to the rhombus only. And those are the 3 major properties with the rhombus. That leaves us with 10 unique properties. If we kind of go all the way back to the parallelogram, which are highlighted right above, right there. That's 5 of them with the parallelogram. We talked about 2 yesterday with the rectangle, and now 3 with the rhombus. That is 10 different properties that is unique to these shapes. And it's important to know which property goes with which shape. That's very important, because if they just tell you have a quadrilateral with congruent diagonals, you need to know that congruent diagonals has to do with the rectangle, not a parallelogram, not a rhombus. So it's important to know which properties go with which one. That's kind of first and foremost. I'm not going to spend too much time going over a whole lot of these because I think they're pretty self-explanatory. I think they're very easy. We're going to utilize these properties in a different way. And that way we can jump right to the last parallelogram, which is the square. So let's just jump to 3 and 4. We'll just do those. We'll do one with sides, we'll do one with angles, and then we'll flip the page. So it tells me that RT is 22. So RT is the diagonal. Because it's a diagonal, we know I'm not going to label the entire diagonal. Instead, because we know that this is a parallelogram, oops, sorry. Since this is a parallelogram, diagonals bisect each other. So I'm just going to label these as 11 rather than labeling the 22. And then it tells me that US is 18. I'm going to do the same thing and label each of these as 9. And ultimately, I want to figure out all the other sides. I want to find VT, UT, all that, all those sides. Obviously, if we know one of the actual sides of the rhombus, we know all of them because they're all the same. So the best way to do it is, well, you have 4 right triangles. The legs to these right triangles are all the same. They're all 11 and 9. The hypotenuse to this triangle is the side to the rhombus, RS. So we're just going to do Pythagorean theorem. So 9 squared plus 11 squared equals, what am I finding? RS in this case. So we'll do that. We'll do 9 squared plus 11 squared. I get 202 is equal to RS squared. And then I just need to square root that. And I get 14.2. Let's just double check those directions, make sure they want us rounded to the nearest tenth. They don't tell us, so 14.2 is fine. So 14.2. And all the sides are 14.2. Which packet is this? This is the one that starts with properties of the rhombi. That's what packet we are on. Front of it looks like this. And that is all the sides to this rhombus. So we got VT, and then we just kind of follow along. VT is 11, UV is 9, RS is 14.2, ST also 14.2. We could even take this a step further. They're not telling us to do it in number 3, but you could figure out all the angles. Remember, these are right triangles. If you really wanted to, and say you wanted to figure out this angle right here, well, it's a right triangle. You could do your SOHCAHTOA. You could go right to SOHCAHTOA, and you could figure out, you have all 3 sides. Set up SOHCAHTOA, figure out the angle. If you find one angle, you could figure out all of them in the entire diagram. Obviously, we're not going to do that, but that is something they could ask. So for the rectangle, all diagonals will be congruent, but for the rhombus, diagonals will have a separate measure. Yes, there's a small asterisk to that statement, though, which we're going to get into when we talk about the square. Rhombuses can have congruent diagonals, but that's what's going to make it into a square. But in general, if it's a rhombus that looks kind of like it does in number 3, they will have a separate measure in terms of their diagonals. Assuming we can first prove it's a parallelogram. We're going to get into these really nitpicky details when we start doing the proofs to them. And then we're going to do some classifications where I give you a certain amount of information and you need to determine what is the best classification you can give kind of on these like little details. But we got to learn all the shapes first. But that's a very good question. And now let's just take a look with number 4. So if you did find that one angle, which in this diagram they do put as 38, you could figure out all of them. And you have a ton of ways you could figure that out. You have a lot of symmetry going on in this diagram. You have the right angles, you have parallel lines, you have triangles. There's a ton of different ways you could use to determine all these angles. So first and foremost, I'm just going to label the right angles. And then I'm going to utilize the fact that I just wrote down earlier. Diagonals bisect their angles. So that means this angle and this angle are both 38 degrees. We jump across to the other side. Opposite angles are congruent. Angle 4 and 5 are the same thing. Now you can utilize any property you want, whether it comes from a parallelogram, a triangle. No matter what, you can get to the next angle. If you figure out one of them, you'll have your answer. I'll just look at a triangle, since we are very used to doing that. Angle 6 is going to be, we can just add 90 plus 38, subtract that from 180. What does that give me, 52? So that means all these angles are 52. Angle 1, angle 2, all of them are 52 degrees. That's every angle. So angles being very easy. So 52, 52, 38, 38, 38. And then where's angle 8? Oh, angle 8 is just one of the 90s. So angles, in my opinion, very straightforward. And that's, number 5 is just going to have you do both, but we're not going to do that. I think these rules are pretty straightforward. Okay? We're going to flip over. Now we're going to talk about the properties of the square. So a square, which seems like a pretty innocent shape on the face of it. Not the best square, but a square is going to be simultaneously all 3 of the shapes we have just discussed. So it will first be a parallelogram. Then, if you remember from the flowchart we looked at yesterday, I'll pull that up in just a moment, that if you can prove that the parallelogram is simultaneously a rectangle and a rhombus, then it would be a square, which means it possesses all 10 of those properties, which is why you can call a square a rhombus. That is a fair classification for a square. So all squares are rhombuses or rhombi, but not the other way around, which kind of gets into that question earlier of, rectangle, will rectangle diagonals always be congruent and rhombus ones might be different? They could be. It just depends. So over to the left, these are all your parallelogram properties, which has to happen first. When we do proofs, you have to prove it's a parallelogram first. You cannot have a rectangle if you haven't shown it's a parallelogram. And this is why some of these things can get confusing. You basically need to show one of these properties first, and then you could show one of the other ones. So the next would be a rectangle, and then the last 3, the rhombus. So if we go to that flow chart, we'll just pull it up really quick. There it is. I'm looking at the right-hand side of it. And this flowchart is very useful because it shows you the order in which you have to prove these things. So you have all 5 properties right on top, right there, for the parallelogram to show you. You remember what we said, you only need to show one of them, and then the other 4 will be true. So you have to first show a parallelogram. Then you have an option a parallelogram could branch either into a rhombus or a rectangle, depending on what properties it might possess. So if you can show a parallelogram that happens to have diagonals are perpendicular, then it's going to be a rhombus. If you can show one property from the rhombus and one property from the rectangle, so let's pretend you can say that the diagonals are perpendicular and the diagonals are congruent. That means you have a square. So that's kind of how this flowchart works. A square is the most specific type of parallelogram that exists. All right. So let's jump back to the notes. I'm not going to do a whole lot of these because squares are, as far as like the arithmetic or the calculations behind squares, they're going to be very easy. So I'm only going to do about one of them on this page, and then we can take a look at other ones. Even the ones that have algebra with them are going to be pretty easy. So I'm not really going to focus too much on those. And then I can we'll jump into some of the coordinate geometry ones. So I think we will use graph paper today. I'll just take a look at number 7 with the square. It just says if TR is 17, and that's the only thing they give you, ideally we should be able to figure out everything about this square. So just by giving me the fact that this is 17, we can fill in everything. But we have to remember it's got all the properties. So there's a ton of right angles in this diagram. We have the ones in the middle because it's a rhombus. So all 4 of those angles are right angles. Where P, Q, R, and S are, those are also right angles. That comes from the rectangle. If you remember in a rhombus, the diagonals bisect their angles. Well, when you bisect a 90-degree angle, you get 45. In fact, all these angles are going to be 45. All the way around. So you've now found every single angle. And this will be true for every square. That's why they didn't need any angles to figure out all of them. The given didn't give you anything. If you know one piece, any line segment to the square, whether it's a part of the diagonal, a side, a piece of the diagonal, which we have, you can figure out everything else. Since the diagonals bisect each other, this is 17. Diagonals are congruent because it's a rectangle, so they're all 17. And then, how are you going to figure out the last piece of information? The sides, I would just do Pythagorean theorem. Or you could do SOHCAHTOA, since you have 45 degrees and it's a right angle. So you could do Pythagorean theorem or SOHCAHTOA. You have that option. I'll just do Pythagorean theorem. 17 squared plus 17 squared equals PQ squared. So 17 squared. And I get 578 for PQ squared. And then we just need to square root that. And I get 24. I get 24.04, so I'll just do 24.0, which all the way around. And we have all of them. All right. I'm not going to do the algebra ones. I think they're pretty straightforward. I mean, number 8, they tell you it's a rhombus. They give you those two sides. All sides are congruent. Set them equal to each other, and then solve for x, plug in. It's pretty straightforward. Number 9, it's a rhombus. Diagonals bisect their angles. Set the two expressions equal to each other. Solve for x. Find the angle. It's really nothing new that this is stuff that we've done in class plenty of times. If there's any questions with it, I will answer them tomorrow. If you want to take a look at it, number 11 right here, they give you FGHI as a square, solve for x. It's the only expression they give you. What we just said, we know this angle's 45. You set 7x plus 3 equal to 45. Solve for x. And I know you all can do the algebra behind it. That's typically not a problem. So I think we will finish that page, and we're going to jump to, there's a homework page that you guys may do. Ooh, I like these questions. I may want to do those. $13. I like these 13, 14, 15, and 16. We can kind of check these off. This is right from the homework. But I do like these questions. They kind of help you think about the different shapes in a different way. Number 13 says, which quadrilaterals always have diagonals that are congruent? So parallelograms do not have to have congruent diagonals. They have diagonals which bisect each other, but they don't have to always have congruent diagonals. That is a property of a rectangle. It is impossible to have a rectangle that does not have congruent diagonals. The rhombus does not have to have congruent diagonals, so I would not be checking this one off. But squares have all the properties, so the square gets checked off. It is likely that the square probably will always get checked off if it is going to possess one of the properties, because it has all 10 properties. Then we look at number 14. It says, which quadrilaterals always have consecutive angles that are supplementary? And you need to think, well, where did that property come from? We haven't used this one in a while. Which one had a property that had consecutive angles are supplementary? And if we go back to these right here, that property came from the parallelogram. So parallelograms must have this property. Rectangles are parallelograms, so rectangles must have that same property. Rhombuses must also possess the same property because the rhombus is also a parallelogram, as well as the square. So in number 13, which quadrilaterals always have them? Have their angles supplementary? It's all of them, because they're all parallelograms. So every single one should be checked off. So yes, it is a property of a parallelogram, but you have to remember that rectangles, rhombi, and squares are classified as a different type of parallelogram, which is why they get checked off. So hopefully that makes sense to everyone. And this is why it is very, these definitions are very picky and technical. So 15, which quadrilaterals always have their diagonals perpendicular? So this was a property to the rhombus. So if it's a property to the rhombus, parallelograms don't always have it. Rectangles don't always have it. The rhombus does. And obviously the square has to, because the square has every property. And then the last one, which quadrilaterals always have diagonals that bisect each other? So if you think to yourself, where does that property come from? That comes from the parallelogram. So you might ask yourself, if that's a property from a parallelogram, which quadrilaterals must have this property? And it's very similar to number 14. It is all of them. So I do like questions like that. So let's jump another page and let's see what we can do here. It says, I am definitely going to be using graph paper, and this is going to be a lot of the stuff that we're going to be practicing. So we're going to practice all this tomorrow as well. We'll start it today. This is going to be some of that coordinate geometry stuff. These are going to be these different types of proofs. And we are going to, I've seen this asked in many different ways, whether it's an extended response and they just tell you to prove if it's a rectangle, square, whatever. Sometimes I've seen it as a multiple choice question. They just give you 4 points and they ask, what kind of quadrilateral does it make? Even for a multiple choice question, That's a long multiple choice question. That's a multiple choice question that's going to take you about 5 to 10 minutes. These problems are not short. They do take a lot of time, and they should always be graphed. So it says to classify a quadrilateral as a parallelogram, rectangle, rhombus, or square, we're going to use the following steps. I don't always use this step because I actually don't use congruency. I'm going to use slopes. You do have the option, just like we did a few days before. You can choose if you would like to use distance or slope. I typically always use slope. There's, again, advantages to that. There's one small disadvantage, which we can get into in the future, but I'm not going to worry about that right now. The first thing we're going to do is we're going to determine if the shape is a parallelogram or not. Before you kind of jump into whether it is a rectangle, rhombus, or square, you must always figure out, is it a parallelogram first? Because you can't go further if it's not a parallelogram. Because they can give you something that, for example, has diagonals congruent, but that doesn't mean it's going to be a rectangle. And we'll kind of see what I mean by that. The best way to see just by eyeballing it is graph it. If we graph the 4 points, you're going to have a really good idea on what the shape is probably going to be. So let's do that first. Let's graph this. So here's my graph. Now I'm just going to write out my points. So 9, negative 4. 8, negative 2. 2, negative 5. And lastly, 3, negative 7. I'm going to graph these. Eight, negative 2. 2, negative 5. And then 3, negative 7. Once you graph it, assuming you've graphed it correctly, you should have a pretty good idea what shape you've just graphed. I'll make sure I give everyone another second or minute or so just to make sure that they have it graphed, if you are graphing it. There should have been everyone should have received 4 pieces of graph paper in the packet that I sent home. So just by inspection, by looking at it, we've appeared to have graphed a rectangle. And if this were a multiple choice question, even if you forgot what to do from this point, I'd hope that after you've graphed it, you could circle the choice that says rectangle. Because very easy to see. If the question was a little bit deeper and it said prove that this is a rectangle, well, this is going to be where it's going to require the math. And I'm going to use the slope formula. You can prove any of the shapes using either slope or distance. And proving a rectangle using slope is actually far easier than distance. And I'll explain why. Because if you're going to prove that it is a rectangle, well, first you must show it's a parallelogram by showing opposite sides are congruent. But if you're using distance to prove that it is a rectangle, you're going to also have to find the distance of the diagonals, which makes it so you have to do distance 6 times. That's a lot. However, compare that to slope. If you do slope, you're only going to have to do it 4 times. You do need to show that opposite sides are parallel, which is what we did earlier. Well, I say earlier, I meant earlier in the week. And we are going to continue to do that. We're going to do our rise over run. We're going to show that these two slopes are the same and make sure that they are parallel. We'll do the same thing with these two sides as well. And we're going to do that right now. So I'm going to find the slope of CB. If you want to use your rise over run, by all means, go ahead. I'm going to do my change in y over change in x. -5 minus -2 over 2 minus 8. Switches to addition. So I get -3 over -6, which is positive 1/2. So for anyone who did the slope, it should have been up 1 over 2. And I mean, look at the line. I have that double negative. Make sure we switch it to a positive. And you can tell, I mean, I'm finding the slope of this yellow line. It should be positive. Yes, we could do slope or distance, but I did explain why distance is something you may want to avoid. You can do it. I'm not going to say you can't. You can do it, but you would have to do it 6 times. You would have to do one for every side and the 2 diagonals. I didn't draw in the diagonals because we don't need it. But you could technically do either. Now I'm going to do the slope to dA. Yes, we can always just look at the graph. I remember I did say that. I said it a few days ago, I guess, but I will always just show the actual slope formula. But yes, you can. It's a great way to check your work. I mean, up 1 over 2, up 1 over 2, up 1 over 2. Absolutely. Just make sure if you're doing your rise over run, you'll get, I forget what it is. You're going to go up 1, 2, 3 over 1, 2, 3, 4, 5, 6. You're going to go up 3 over 6. Just make sure you reduce it if you are doing that rise over run. Regardless on how you do it, we should all be getting the same answers. So -7 minus -4 over 3 minus 9. Which is also another benefit of doing slope in the first place. You can use the graph. If this were distance, you cannot count how many units these were. And I get -3 over -6 again, and I get positive 1/2, which tells me that this is parallel. Now I need to do the same to the blue sides. So you'll notice the process of what I'm doing right now is exactly what we did with the parallelogram, because that is what I'm doing. I'm trying to show it's a parallelogram. I'm ignoring the rectangle fact right now. So we're going to do the slope to CD. Just by inspection, looking at the blue line, it is going down. So I am expecting a negative slope right here. Let's check it out. So CD, it's -7 minus -5 over 3 minus 2, which gives me -2 over 1. Does that say -7 plus 4 over? Yes, that is what it does say. I'll zoom in so you can read it a little bit easier. And you might have noticed something about the slope I've just found. If you've noticed it, you can type it in, because I'm not going to say it just yet, because I'm going to find the slope to the other one, but you might notice something peculiar about that slope. The next one's going to be the slope of BA. Which is going to be -2 minus -4 over 8 minus 9. 8 minus 9, this becomes addition. So I get positive 2 over negative 1, which is the same thing as negative 2 over 1. We get negative 2 over 1 twice, which makes these parallel. Yeah, so negative reciprocal. That is definitely one of the keys we were looking for. This is a rectangle. And this is also why I write it out this way, because this tells me that if these slopes are negative reciprocals, these are perpendicular to each other. This is something we did way back in October. We've seen it on plenty of weeklies since then. Negative reciprocals means they're perpendicular. Perpendicular means this is a parallelogram with right angles. And I mentioned yesterday that a parallelogram with at least one right angle is a rectangle. No, it says negative 7 plus 5, not 4. Yes, correct. Now we're going to get into the explanations. When we're explaining, we're going to explain it's a rectangle because that's its closest classification. I'm going to first give my explanation to why this is a parallelogram, just like I did the other day. So we're going to say quadrilateral. ABCD is a parallelogram since opposite sides are parallel. You can basically treat it as one sentence per classification. The parallelogram has to come first. You can't jump to the rectangle. Then you can't go rectangle then parallelogram, because then you are not following the proper order. Just like if you think about it, like when we did triangle proofs, you had to use side angle side before CP/CTC. This is kind of the same thing. Are we gonna have a test on this when we come back? I don't know. We'll see how far we get. We'll see what. That's a good question. I honestly don't know. It wouldn't be the day we get back. If we did, it would be some review, because I know there's plenty of people who are not here. Let me just get into the last statement, which is now we're going to say it's a rectangle, but now I can call it a parallelogram. I don't need to call it a quadrilateral anymore because I've just classified it as a parallelogram. So parallelogram ABCD is a rectangle since adjacent sides are perpendicular. We know they're perpendicular because we just found the negative reciprocal. And that's how we would classify it to the closest classification, especially if it was an extended response. And this is a full-on proof. And these are going to be the proofs we are going to practice tomorrow. We'll look at what does a proof like this look like if it's a rhombus, what does it look like if it's a square. We're going to do every single shape and classify these based on their coordinates. So this is a proof. You'll notice it's very different than the statement reason proofs. But this is technically what a coordinate geometry proof looks like. All right. Do I want you to hand this all in when we get back? No, I'm not going to have you hand anything in when we get back. The only thing I'm doing is I'm not reteaching this stuff. My expectation is when we come back to school that you know this stuff already. So the people who are here are going to be in a much better position for the class going forward when we come back. You can practice the previous homework if you'd like, the one on the rhombus and squares. We will continue with this tomorrow, graphing these, proving these, and so forth. All right, we are done. If you guys have any questions, please type them in chat, and I can get to them. Could we do the notes on the top quick? Of this page right here? I'm ignoring them because we're not using congruency. That's why I did not fill them in. So I've purposely left that out. especially because we are using slope, or I'm using slope. All right. All right. Thank you guys. If you know someone is not here, please redirect them to the YouTube, to these, or the Twitch, or anything like that. You're welcome.